Hey everybody in Algebra 2. We are here picking up with the last part of 7.5. This should not take very long, but I just feel like I need to work some of these through. Since we haven't really used the properties of logs full out in solving them. We've done it in rearranging them and rewriting them, but you've done these solving equations with logs when you had logs on both sides of the equal sign. That was super easy. So now we're going to look at things like know how to go back and forth between log form and exponent form. That's going to be the easiest thing. When you get stuck in one, you're going to realize it and you're going to go, oh, well, let me shift it to the other. If you have log on both sides, let's say you have log base b some Brock equal to log base b some Brock. Okay, at that point you can cancel those out and you can just set your Brocks equal. So if there's a log on each side, it's super easy. If there's not a log on each side, you're going to find yourself having to go back from one form to the other to find the solution. And remember, you can never have a negative Brock, so we want to make sure that we check them. Okay, so let's look at a first example. This is Rex number 1. Remote example number 1. Solve. Okay, log base 6 Brock of x plus log base 6 Brock of x minus 9 equal to 2. Okay, the first thing you're going to notice here is that you only have logs on the left side, not on the right. Okay, so if there was one on the right, we could combine these two and then cancel out the logs, but we don't have that. But that's okay. We do know that addition leads to multiplication of the Brocks, so we're going to rewrite this as terms of a single log on the left, log base 6. Brocks are going to be multiplied x times x minus 9 equal to 2. Okay, so that's our log statement. Now, you will realize right here that I have put it in log form because it's got the word log written one time. I've got a base, right? I've got a Brock, and I've got this guy over here, which you know to be the exponent. So all we're going to do is go from log form to exponent form. Okay, and you know how to do that. Get rid of the word log. The base is going to come over here and he's going to bump that exponent up into place. So I'm going to rewrite that as x times x minus 9 is equal to 6 squared. Okay, x times x minus 9 is equal to 36. All right, now we're going to have the makings of a quadratic, right? So you're going to have to multiply this out and you're going to have x squared, excuse me, minus 9x minus 36 equals 0. Okay, now we have a quadratic, which means we're going to have to factor this. You guys know how to factor. This one's easy. It's got a lead coefficient of positive 1. The signs here is negative, so the signs in our houses is going to be different. I need two factors of 36 that are separated by 9. That would be 12 and 3. So you can go ahead and make your houses, and knowing that I'm going to need a negative 9, so 12 is greater than 3. These are my factors. 12 is greater. I need a negative, so it's going to be x minus 12, x plus 3. All right, each of those gets set equal to 0 separately. Okay, subtract 12, subtract 12. So we have x is equal to negative 12. We will put that in scrolls. And we have minus 3, and we say x is equal to negative 3. Now, we're not sure if those are valid. We have to test them. Okay, so I want you in your mind to put an invisible question mark. You're like, I don't know yet. I'm not going to say it is. I ain't going to say it ain't. But let's test it. So let's look at negative 12 inside of our original problem. So if we go up here, we're looking here, and we're looking here. Wait, I messed up somewhere. Oh, that should be positive 12. I'm so sorry. I goofed. That should be positive 12. Okay, so let's test positive 12. Well, positive 12 in here is a positive Brock. That's cool. And then we have 12 minus 9 would leave us with 3. So that's cool. So we would have both positive Brocks, so we're not violating anything. So positive 12 is definitely in. Okay? Negative 3, I can tell you right now, that is not going to work because negative 3 here, if you test it, it's going to give you a negative Brock. And negative 3 minus 9, it's going to give you another negative Brock. So negative 3 is out. So the only solution to this example is 12. Whoops, sorry. Beep. There it is. So that's the only solution to this Rex, number 1. Okay, so all we did is we used our properties. We condensed it to a single log on the left. Once we did that, we realized we were in log form and we were stuck. So to get unstuck, you put it in exponent form. Base went over, swung up, pushed that exponent up. That gave us 6 squared on the right-hand side, which was 36, right? Oh, over here, my bad. And then we just distributed this because we need to create a quadratic. We moved the 36 over, set it equal to 0, found our factors, and then we tested them. And positive 12 was a win, negative 3 was a fail. Okay, so that's that example. All right, let's do another Rex. Rex number 2. Now, I want you to notice we are not using something that's called log base E. I'm going to introduce you to you tomorrow, or probably when we get back from Easter. Okay, so that's the same thing as saying ln, which means natural log. Okay, but right now we are dealing with non-base 10 logs, which means it's log base B, but it's not E. This is a special kind of log, and we're getting into that. But right now we're in chapter 7.5 still, and we're finishing up. All right, let me give you another Rex. All right, let's look at this one. Solve 2 log base 7 of x equals log base 7, 27, plus log base 7 of 3. All right, you're probably looking at that and you're going, you know what, that looks good because I got logs all over the place. I got them on both sides of the equal sign, and I'm going to be able to take care of that after I shrink some stuff down. All right, first thing I recognize is this log statement here. He's got a coefficient. We're going to put him back over here, and that's going to give me log base 7 x, and my Brock has an exponent of 2, and I got to watch my time. These logs are separated by addition. They are both base 7, so they're cool. So you're going to say log base 7, and I'm going to multiply my Brocks together. 27 times 3, okay? Because addition leads to multiplication. All right, now here's what I've got. I've got log base 7 x squared equals log base 7, 27 times 3. I can get rid of the word logs, and now I have x squared is equal to, and I don't know what that is at the top of my head, so give me 1 second, 81. Okay, we have now a square root property. We don't need to factor this one because we have a quadratic and a constant. So automatically, you're going to take the square root of both sides, but remember, when you're taking the square root of both sides, you have to account for a plus or minus situation. Doesn't mean both roots are going to work, but we have to put it out there. So we have x equals negative 9, and x equals positive 9, and we don't know, so we need to check. We're going to go back and we're going to say, okay, obviously this guy is out because you cannot put a negative in for that Brock, so he's goner. Positive 9 worked there because he's a positive Brock, and yeah, that's it. All right, so 9 is our answer there. Okay, so that one we ended up with log on both sides. We were able to cancel it out, and x squared equals 81. Square root property took square root of both sides, and we tested, and negative 9 did not. Okay, don't forget your plus or minus on these types. Okay, so there's that one. All right, I think I have time for one more quick one. Gotta time these videos. All right, let's try this. I think that's Rex number 3, remote example. Log base 6 x plus log base 6 binomial x plus 5, is that Brock, equal to 2. All right, so we're going to solve this, and we're going to solve for x. And you can see that addition is going to lead to multiplication, and multiplication of these two is going to lead to a quadratic. So we may have to factor again. All right, so we can write this in terms of a single log. Okay, and that means log base 6 of x times my other because addition leads to multiplication, so that's x plus 5, and that's just equal to 2. All right, now we are stuck in log form. I could go ahead and do this. I'm going to anyway. But now we're going to have to get rid of him, push him over here, and push him up. So x times x plus 5 is now equal to our base of 6, which moved over here, and we bump the exponent up into the exponent position. So now we can distribute x squared plus 5x equals 36. Subtract 36. Okay, so x squared plus 5x minus 36 equals 0. We're going to factor this. Super easy. I need two factors of 36 because this is different, right? That differ by 5. Well, that's clearly going to be 9. Wait a minute. Pause. Okay, so it's going to be x plus 9 and x minus 4, because that's going to give me the positive 5 that I need. All right, so that's going to give me x equals negative 9 and x equals positive 4. So I put a question mark so we can check them. Well, if you go back up and you test negative 9, you're going to see immediately if you put him into that very first expression in place of that block, he's a negative. So that's a no-go. Okay? 4 is going to be completely legit. We put 4 in here, it's a positive block. You put 4 in here, it's 4 plus 5, which is 9. So 4 is a winner. So scrolls 4. Okay, that's all for this video. I will make another one in this series.